The approach of using avidin conjugated with drugs or other positively charged nanoparticles or peptides are certainly possible, and we're exploring these other particles as well. The concept could involve a combination of drugs, not just limited to one drug, and this has been a debate within the orthopedic community as well as to whether a combination therapy could be efficacious. If there is early cartilage degeneration caused by a joint injury, that could, such degeneration might be halted by using certain classes of drugs like glucocorticoids at very, very low density, very low concentration in the joint, so that one wouldn't worry about the effect of the drug itself. You might be able to halt the degradation, but then there remains, if you caught this problem where the cartilage had already begun to degenerate, could you induce the cells to regrow or repopulate the tissue with new matrix molecules? And so another class of drugs that might be very important and interesting to try would be anabolic growth factors. And again, these drugs can be used at extremely low concentrations because instead of just injecting into the joint very high concentrations of a drug, hoping that it can diffuse into cartilage or other tissues, if you start by having the drug carrier bring it into the tissue, then you can use low doses. So we and others, other labs have been trying using anabolic growth factors for a variety of experiments with cartilage over the years. One that we've been looking at is IGF-1, insulin-like growth factor 1, a well-known growth factor that can induce the chondrocytes in the extracellular matrix to synthesize new extracellular matrix and lay it out. This is certainly has been demonstrated by many groups over the past 20 or even 30 years in laboratory studies involving pieces of cartilage cut from animal joints and placed into culture, live culture, where the medium is then filled with a growth factor like IGF-1. The growth factor can diffuse into cartilage and upregulate production of new matrix. Again, the challenge is it's easy to do this in an incubator in the laboratory where the 24 or the 96 well or the 386 well plate has medium with growth factor in it, and it's bathing the tissue all the time. You don't want to inject a human joint multiple times every day for the next year. You want to do it once if you can, just once. And so could you functionalize the nanoparticle with a drug of choice? It could be a combination. For us right now, we're just trying, as an example, IGF-1 and dexamethasone together, where the dexamethasone can suppress catabolic events, degradation events. The IGF-1 can upregulate anabolic or growth of new tissue and see if that can occur. The challenge with cartilage, again, is the dense extracellular matrix. So the tissue in humans is kind of about 1 millimeter thick. It's filled with a matrix, and one of the main problems for us is that our cartilage has a very low density of cells called chondrocytes. Only 3 to 5% of the volume of the cartilage has these cells, and therefore if there's an injury, it's very difficult for such a low population of cells to repair the tissue. Hence the problem that begins all of these studies. The cell, when it's challenged in a joint by an inflammatory environment and mechanical injury, might be secreting enzymes that begin to chop up the extracellular matrix, and therefore the targets for a drug might be several. It could be the cell itself. So if you can bring a drug like a growth factor to bind to a receptor on the cell and modify the cell behavior, that's great. It could be that matrix molecules are being degraded by enzymes produced by the cells, and therefore there are targets in the matrix itself that you might want to block. People have tried enzyme inhibitors, and again, those kinds of trials have failed in the past because of the lack of an appropriate delivery scheme in some way. But it could be that some of these previously wonderful pharmaceuticals that failed because of systemic side effects might still have an efficacious response if delivered very locally and not systemically to a small region inside the cartilage. That whole area remains to be re-examined and rediscovered because there are some marvelous things that have been produced in the past decades.